Hello and welcome back. Today we are covering encoding, what it is and why it shows up everywhere in applications. I'll demo Base64, URL and character encodings so that you can spot and decode them easily during your analysis. Encoding transforms data to a different format for compatibility and safe transportation, for example over the internet. Unlike encryption, encoding is not meant to protect data. Anyone can decode it easily back. However, some developers sometimes use encoding to slightly obscure strings and make it harder to find them in the code. For example, hiding URLs so that they don't appear when you search for HTTP in the application's code. Common encoding methods are Base64, UTF-8, hex, and URL encodings. First, we will look at Base64. Base64 is commonly used to store binary data in text format. For example, embedding the image, storing credentials, or including a key in a JSON. It's simple to use and very common in apps. Some developers encode strings using Base64 to make them less readable during static code analysis, but it doesn't provide any real protection. An experienced reverse engineer will recognize Base64 immediately. For example, URL encoded in Base64 will start with these symbols, which means HTTP. Now let's check URL encoding. This is used when URL contains reserved characters, such as spaces or non-SCI symbols. URL encoding replaces this with specific % sequence so that the URL can be transmitted safely and opened by servers and browser. And one more type of encoding is character encoding. This defines how text characters are represented by bytes. The most common and recommended encoding for symbols is UTF-8 since it supports all languages. When encoding is mismatched, you will see just gibberish and unreadable text. Now when we know what encoding is, let's look at it on practice. I've created a small application with examples of encoding and decoding and used Base64, UTF-8 and URL encoding. Let's go through the code step by step. At the top, I have two sample strings, a URL and a text that includes English and non-English characters and emojis. That way we can clearly see how different encodings handle both normal and specific characters. Here I first encode both strings using Base64 and log the results. Then I decode the same strings back and log them again. So in the logs we will see two encoded values and then two decoded ones, making it easy to compare them before and after. Next we move to URL encoding. We have here the same flow as with Base64. And finally we proceed to characters encoding, and this part is especially interesting. Here I convert the string into bytes using the UTF-8 charset. Then I log the raw byte arrays to show how the data actually looks in binary form. And after that I decode those same bytes twice. Once using the correct charset UTF-8 and once using the wrong one, ISO. This helps to demonstrate what happens when the app uses the wrong encodings. You get broken or unreadable characters. And just like before, I log everything. Now let's run the app to check the logs together. First, the Base64 section. We can see the encoded URL, it looks like random letters and numbers, and the same with encoded text. Then we see them decoded back to their original readable form. So Base64 doesn't hide the data, it just changes how it is represented. Anyone can decode it back easily. Now let's check URL encoding results. The encoded URL looks like this, and the encoded text has those long sequences representing Cyrillic letters and emojis. This is how URL encoding safely carries any characters across the web. But again, it's not encryption, it's just formatting. And finally the characters encoding section. Here we see the raw byte arrays for UTF-8, each character represented by one or more bytes values. When we decode those bytes correctly with UTF-8, the text looks exactly as expected. But when we decode the same bytes using ISO, we get broken characters like this. That's what happens when the wrong charset is used. The bytes are fine, but the interpretation is wrong. And before we finish with encoding, let's also take a quick look at CyberChef again. As I have shown you before, CyberChef is a universal tool that handles all transformations of data. You can easily decode everything we saw in this demo just from your browser. Let's check it quickly. We copy our Base64 encoded string, open CyberChef and drag the from Base64 operation in the recipe field. After that we just paste our encoded value in the input window and instantly we can see the original text decoded at the right side. No key, no passwords, no tricks. It's just automatic because encoding is always reversible. The same goes for URL encoding. If we paste the encoded URL and choose URL decode, CyberChef immediately shows the readable text again. It's a great example how tools like this make encoding extremely fast. And also why encoding should never be used instead of encryption. And finally, let's test charset encoding. If we paste our UTF bytes or text and select the decode text operation, then set the input encoding to UTF-8, we will see the correct text appear. But if we change the encoding to something else, for example ISO, we will immediately see the broken characters appear, just like in our logs in application. So to summarize, encoding is all about compatibility, not security. Still, as a reverse engineer, you will often see encoded strings when analyzing applications. Correctly recognizing the encoding format can save a lot of time for you. And with experience, you will immediately recognize all encoding formats easily. So that's encoding. It doesn't protect data, it just changes the way it is represented for storage and transmission. I hope this video helped you, and if it did, please put your like and subscribe, and share this video with friends who might find it useful. Thanks for watching.